Recording in progress.
Yeah, comes on everyone. Let's start off. Last thing that we did, we started with projectile on an incline. Great. Let's go ahead with one more question. Others do keep your cams on. So this side is 60 degrees and this is 30 degrees. So someone projected a particle here from point A perpendicular to the incline. So you projected with speed u perpendicular to the incline. So this thing went in there and it hits the incline, the other one, again perpendicularly at point B with speed v. This height here is HA. This height here is HB. So A and B are 2 points on the incline. The particle is projected perpendicular to the incline from A and lands at point B, again perpendicular to the other incline. So this is the thing that is happening. So, and u ka value is given. So the initial speed u is equal to 10 root 3 meters per second. This is the speed with which you projected. First thing, find it. Find V. V is the speed where it hits the incline there at B. Find time of flight. Time of flight means time taken from to go from A to B. Find HA and HB. What is the height of point A and point B from the ground level? Okay, let's get them all. This would be a good paragraph question. Hope the whole scenario was clear. Anyone not clear with the question, please ask me. Okay, get the remaining also, Yukti. How do we start? Yeah. Yeah, got the time right. Yukti, time is right. Okay, let's see the first part. How to find the speed. Now we can actually use the normal ground frame ka thing. Observe this. This was 90, this was 90. So horizontally, if you make an angle here, this is 30, this is 30, this was 60. This was 60, this is 60, so this is 30. This speed is v and this speed is u. We know in a projectile motion, the horizontal velocity will never change. Why? Gravity is always vertical, right? Horizontal velocities are unaffected. So be careful with that. If there is no horizontal acceleration, only then u cos theta is v cos alpha. The u is 10 root 3. Cos theta is cos 60. Cos alpha is this angle. We should take the horizontal angles here. So that will be v into cos 30. So this thing comes out to be v is equal to how much? 10 root 3 by 2. 2 will cancel. Yeah, 10 meter per second. Yeah, that was the first part. You got the v velocity directly from there. You have to find h1 and h2 separately. Find HA, this height, and HB. Not relation. Is the first part clear, everyone? So we can just use the horizontal velocity and you can get it from there. What about the second part? Time of flight. How will you do that? Try. I'll give you another minute. Yeah, Anish, time is right. Karthik, time is right. Okay, let's see the time of flight. Now, if you observe here, right, there is something about this picture. The angle between the inclines is 90 degrees. So that's a very good information we can use. Uh, so see what we will do here. Consider this as your y-axis. You can choose anything as your x and y. They should be perpendicular. And I will choose this direction as x-axis. Okay, so I choose my x and y-axis from here. Now just rotate this bit and write the components here. So if you click at the velocity, so this will be y direction. So uy is equal to u, ux is equal to 0. So initially there is no horizontal velocity. There is only vertical velocity. Finally, in this direction, if you see velocity is in this direction. So final velocity vx is v, which is 10 meter per second, and vy is 0. Everyone agrees with this? So initially when you're launching, there is no horizontal velocity, I mean there is no x component, but there is a y component. When you're landing, there is no y component, but there's an x component. And what about acceleration? This is gravity g. So remember, we are taking this as x. So we will resolve into components. This will be g cos 30. This is your ax. This is your g sin 30. And this is g cos 30. This is ay. I hope everyone understood how I got that components. Because you have taken this as inclined, right? If you're confused about that, I can just show you very fast here. See. So if this is 30 degrees, the gravity g was here. This angle will be 30. So this component will be g sine 30, and that component will be g cos 30. So now if you rotate the whole problem by 90 degrees, can you see everything becomes x and y axis and everything? And what is this distance here? If you look at this distance here, this distance is your sy, the y coordinate. What is this distance here? This coordinate is sx, the x coordinate. Everyone clear with the picture, right, Karthik? This is the, before going ahead, any doubts on this picture, please ask me. I have taken the initial incline as x-axis, the final incline is y-axis. Because it is 90 degrees, that makes our life easy actually. Then I resolved the acceleration perpendicular to this and in this direction. So I divided the acceleration x-axis, y-axis. I got the velocity initial, final. I got everything in terms of that. And now, so Vy is equal to Uy plus Ay into t. What is the final velocity Vy? 0. What is initial velocity? U. What is Ay? G cos 30. When you land there, what is the time? That is your time of flight. U is how much? 10 root 3. G cos 30 is 10 root 3 by 2. So from here, we get time of flight is equal to 2 seconds. You cannot use your regular formulas because it does not come to the same level of projection. This picture is more important. Please understand the picture. So when you see the initial data, right, 60, 30, 90, that should have triggered boss. I could take x and y axis this way. But unfortunately, let's say if this is 45, you're dead. Then this will be very complex to solve. You can still do it. You can still take this as x and y and can be done, but it'll be more complex. It won't be like this way. Any doubts on this page? And once we got this, I'm just using the same three equations again. So Sx is equal to uxt plus half ax t square. What is ux? 0. What is ax? G sine 30. What is the time? 2 seconds. This will give you that x coordinate, that Sx, which is sine 30 is half 2 goes of 10 meters. Similarly, I can use Sy. Sy is equal to uyt plus half ayt square. Uy is u, which is 10 root 3. Time is 2 seconds. Ay is negative, so half minus g cos 30. 2 square. This is 20 root 3 minus 2 will cancel, that is 10 root 3. This is 10 root 3 meters. This is not the answer. Huh? This is Sx and Sy, which are these distances. But once you got this, now look at that incline. This was point A. This was Sx, which was 10. You are asking for this height, HA, and this angle is 30 degrees. So sine 30 will be HA by Sx. So SA will be 5 meters. 10 sine 30. This is Sy, which is 10 root 3. This was point B. This is the height HB. This is 60 degrees. Sine 60 is HB by 10 root 3. 15 meters. Clear with the steps? So once you got Sx and Sy, but remember Sx and Sy are the distances along the incline. So you need to drop the perpendiculars again. That is how you use the incline ka stuff here. Like I said, the main thing was the picture. If you got this, then you're done. Yeah, there are other ways also to do this, but this is a little easier. Any doubts on this? You could have done in the normal way also because you already know the velocity here and angle. You could have resolved this into v cos 30, v sin 30, u cos 60, u sin 30, and you could have used the regular projectile also. It works. Like I said, there are always, one or two ways to do. Nothing wrong. You can see whatever works well. That's a little about the inclines, but that is the main theme in all these incline problems. You resolve the accelerations in x and y, and then you finish it off. Great. So before going ahead, let's do one more question. Let's say we have an elastic wall. What is an elastic wall? So let's explain what is an elastic wall. So in an elastic wall, if a ball is coming with some speed, let's say ux and uy, and the ball is coming at an angle, after colliding, the ball will bounce off, just like the law of reflection. So this component ux will reverse, whereas the vertical component ui, the one parallel to the wall, will remain same. So that's what happens whenever you hit a wall. Just like principle of reflection. So the component perpendicular to the wall will reverse. And the parallel component will be unaffected. Component parallel to wall is unaffected. More about this, we have a separate chapter for this. So let me take an example here. Let's say we have a ball which is coming with 5 meter per second and 10 meter per second. So when this ball goes and collides here, after collision, the ball will continue to go up with 10 meter per second, but the velocity will reverse here 5 meter per second backward. So this is before collision and this is after collision. I hope the idea is clear what happens with an elastic wall. That's a little story about an elastic wall. So whenever you hit an elastic wall, this is what happens. Now the question, you projected a particle with u and theta. This thing goes and hits the wall. After hitting the wall, it bounces and falls on the ground. The distance between the wall and the projectile is d. And it hits the ball and falls here. Let this distance be x. Range, which is u square sine 2 theta by g. That is your range. And this value d, right? R is greater than d. So definitely it is going to hit the wall. So using this information, so the ball hits the elastic wall and falls on the ground. Find x. So x is the distance between the wall and the point where it lands. Answer you can give in terms of R and D. I hope the whole story was clear. I'm sure you must have done something like this, right? You throw a ball onto a wall, hits the wall and comes back and hits the floor. Later on, when we do the questions, right, and collisions, questions will be like this. The ball will go hit the wall, fall on the floor. Again, it will bounce and come back to the initial point. We will do all those kind of things later on, but okay. This would be a starting thing. So let's get this thing. Anyone didn't get the question, please ask. Questions clear? Go ahead, I'll give you a minute. Use logic. Don't try to write equations and solve. Yeah, right, Karthik. Yeah, Anish. Yeah. So let's see. Listen to this thing. Think of like this. Imagine there is no wall. This idea is important. Imagine if there is no wall, then what would have happened? You and theta, you would have just gone like a regular projectile and you land somewhere here. Now, because you kept a wall here, now again, understand what happened. The collision didn't do anything. It simply reversed your velocity. Meaning at this point, you are going with u cos theta and your vertical velocity was Vy. So after hitting the wall, only the u cos theta will reverse. After hitting the wall, the u cos theta reverses, but the magnitude remains same. And Vy remains same, meaning nothing will change in the vertical direction. This is what we said about the elastic wall. That means whatever should have happened on the right hand side, the same thing will happen on the left hand side, like a mirror image. So the path would be a mirror image about the wall. So if you take the wall like a mirror, if you put a reflection of it, you can actually fold the parabola. The path would be a mirror image. About the wall, meaning this is how the picture would look like. So when you project it with u and theta, you would have gone like this and you would have hit here. So if the wall was not there, you would have continued like this, the green one. Now it will do on the same thing on the other side. So, so this red one here and this one here would be a mirror image. So how much will this distance be? This distance was d, so the whole distance was r, and this distance was d. That means this distance is r minus d. Since it's a reflection of it, this distance will be x, which is also r minus d. That's it. Therefore, x is equal to r minus d. Is that logic making sense? Yeah, so no need to solve that. So you are what you're doing, right? You're taking the full parabola and you're folding it here, isn't it? So you can think of like this. Draw the full parabola, cut it here, and fold this red line on the other side. So if you fold it on the other side, it will become like this. Making sense? You're just folding the parabola. Every time you hit a wall, you fold the parabola. Is this idea clear? Now the actual question. This was not the main one. There are two parallel walls. Both are elastic walls. The distance between them is 3r by 13. R is the range. Now you projected the particle with u and theta from this corner. Let's call this corner A and let's call this corner B. Now what will happen? This will hit the wall, hit the wall, hit the wall, bounce, 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 and will fall somewhere, isn't it? The ball will keep on bouncing. So you get multiple bounces here. Find the point where the ball lands on the floor. Find H max and time of flight. Neglect the time interval during collision. So during collision, there will be small time, you're neglecting it. So this folding the parabola, right, is a very interesting concept. Matlab, you can do this for different shapes. Let's see how to do this. Hmm. The story is still the same. Every time you hit the wall, vertical will be unaffected. Only the horizontal will keep shifting right, left. Hmm. Okay, let's see. Anish, maybe right. Looks right. Hmm. Yeah, right, Prisha. Nee, Ahna. Anish got it. Nee, Ahna. Numbers are not 3R by 13 diya. It's not an exact multiple of 13. Again, what is the idea there? Think of like this. What did I say right now? If there was no wall, what would have happened? If there was no wall, you would have gone like a regular projectile, right? Now, what I'm suggesting you to do, now because there are two walls, and this is 3R by 13. So take this parabola and cut it into 3R by 13 ka pieces. So let's cut it. So this was 0. So cut it into one piece here, 3R by 13. Cut it into one piece here, 3R by 13, 3R by 13, 3R by 13. And the last piece will be R by 13. This will be 3R by 13, 3R by 13. Got it? Now see what would happen. The first part. So when you're going from here to here, I'm marking it in green here. So you're going from A. So this is the first collision. The first collision or the right wall, I'll call it R. So from here to here, you'll go here and you'll call. So basically, you take this green one and put it between the walls. So this is the first collision. Point one, point one. Next one, I'll mark it in black. Now remember, this thing is going on the left-hand side now. You're hitting the left wall, I'll call it L, point two. You're going like this, you're hitting the wall here. Picture is not up to scale. Something like this. So this is point two. Then I'll mark this in some sky blue color. So this is point three, right wall. So from here, you're going and hitting the wall again here. This is point three. Then again, this thing I'm putting in orange here. Again, you're hitting the left wall, point four. So from here, you're hitting the left wall, point four. The last part, let's say this thing, you're hitting this thing on the floor here, point five. So from here, you'll hit the floor here, point five, and this distance will be R by 13. Are you getting what I did? So you are simply folding the parabola every time. You take the parabola, every R by 13, you fold it, you fold it, you fold it. You have to fold the entire parabola between the two walls. Is the logic making sense? So the path would look like this. So you'll go like this, then like this, like this, like this, and then you're done. 1, 2, 3, 4, 5. So that's how you handle that. You take a parabola and you just keep folding it. No need to write any equations or do any big thing. You can just visualize and see. That's how you fold a parabola. And if you observe this thing during collision, the horizontal velocity will never, vertical velocity will never change. Vertical components are unaffected. Because when you hit a wall, only the u cos theta will change direction. That means your h max and time of flight will remain unchanged. Therefore, h max will be u square sine square theta by 2g. Like I said, I didn't draw it up to scale, but this height here and this height here will be exactly same. Time of flight is equal to 2u sine theta by g. All clear with this? So that is the thing whenever you're colliding with the walls. And you can keep playing with this. You can even create more variations. You can create even more tougher variations. Like if I had to give an example, think of like this. I'll just give an example you can think of. Let's say there is a well, cylindrical well. The depth of the well is h, and the radius of the well is some radius r or something. Okay? This is the center. Okay, so a ball. This is the side view. Okay, so the top view on the floor. The ball is coming here with an angle of some 30 degrees. You getting how it is? Uh, Again, if you're looking into my screen, think of like this. So this is the bottle is there. This is the well. So the ball is coming like this and falls into the well. You getting it? Meaning, if I draw the top view, picture will look like this. Top view will look like this. So from the top, it looks like a well. So the ball here is coming this way. So this ball will go into the well and it will fall inside. It will hit the walls of the well. It will bounce, 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 right? And bounce, 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 and again comes back from here. So it will go inside. It will hit here. If you see from the top view, it looks like this. It has gone like this. It looks like a straight line, but it is actually going down inside, isn't it? And then it bounces again somewhere here. Then again it bounces here and it comes out like this. This angle is 30. This angle is 30. So this angle is 60, 60, and 60. That forms a equilateral triangle. Then they can ask you. So, you know, what is this? So this straight line which I'm drawing is actually a parabola, isn't it? So from here to here is a part of a parabola. Parabola. I mean, I didn't draw it again properly. Like this, something of this sort. So here you have to fold the parabola in 3-dimensional. Are you able to visualize? And if I have to show it right, it looks like this. Look into my screen. If this paper was a parabola, right? I know it's not, it's a parabola. You have to fold this into 3 sides and make an equilateral triangle. This is how it would look, isn't it? Like an equilateral triangle. So you have, so this is how the whole parabola is. If this is the whole parabola, so fold the parabola at 60 degrees, fold the parabola at 60 degrees and make an equilateral triangle with the parabola. समझ में आ रहा है? That put that parabola inside the cylinder. But think about it logically. Didn't we do the same thing here? What we did here, we took the parabola, we folded it multiple times, and then we kept it between the walls, isn't it? Is that the logic we did? We took the parabola, folded and kept it between the walls. If you give me a cylinder, I will fold the parabola like an equilateral triangle and put it in the cylinder. You guys able to visualize that logic? That's it. So that is the main theme there. You can always fold the parabola as long as you understand that. That's great. Meaning, imagine अगर ये angle change किया. Let's say this angle was something else. Instead of 30 degrees, if it was 15 degrees, then what would happen? This would be 30, right? Now it won't form a triangle like this. 30 degrees, so it will hit here, it will hit here. It will actually form something like a 60 degrees. So 30, 30. It will form something else. It will form a pentagon or something, hexagon. So the shape will keep changing inside. Every time you won't get a triangle. For example, if this was 22.5 or something, you'll get 45, 45, 90, 90, 90. If you take 45, 45, then you get 90, 90, 90, you get a square. The shape inside will keep changing. You have to fold the parabola like a square and then put it inside a cylinder. Something like that. We'll see. I'll try to give it in some exam. But all clear with the folding parabolas? More about this we will see later on. We have a chapter called collisions. There we will deal with it in more detail. But folding the parabola is a thing. Any doubts on this? Because the motion what you're doing is only the u cos theta keeps changing direction. So whatever is supposed to happen front happens in the other direction. So you have to think from that perspective. Next thing, relative motion. This is another subtopic and important thing. Now, in certain cases, it is convenient to solve with respect to moving frames. Right? Now, why is that? Simple example. Think of this thing. If I ask you this question, if you're standing on the sun and if you're looking at the moon, what is the path of the moon? If you're standing on the sun and if you're looking at the moon, how does the moon ka path look like? Motion of the moon, or the path of the moon with respect to sun. It looks really complex, meaning if you actually standing on the sun and if you try to look at the moon ka motion, you will see this moon is going in some jalebi motion, isn't it? Ever seen this kind of thing? It looks like a jalebi kind of thing. So this moon is going something pretty weird. It becomes very difficult to study this. But if I suggest you this thing, forget about the moon. First, look at the sun. Look at the earth. Stand on the sun and look at the earth. So motion of the earth with respect to sun. Then stand on the earth and look at the moon. Now what you will notice, so if you stand on the sun and if you look at the earth, it is almost a circle. So this is how the earth looks. And if you look at the stand on the earth and look at the moon, that will be almost another circle. So actually, this motion, the jalebi motion which we're talking, which is so complex, is actually a combination of two circles. Isn't it? So if I want to study the moon ka motion, I will not study directly. First, I'll study Earth. From Earth, I'll study the moon. So by splitting the motion into two different parts, that makes our life easy. You're getting the logic there. So that is what will make your things easy. So by standing on a moving frame, it makes certain times it is easy. So how do we study this? We will do most of the things with the pictures, right? Meaning mathematically it is the same thing, but pictorially it gives you a more feeling like, oh, this is what is happening. So how do we study this? Idea is pretty simple. In max, did you guys study this shifting of origin? If I want to make 3 comma 4 origin, how do you shift origin to 3 comma 4? The idea is very simple. You give -3 and -4 to everyone. Everyone in the space give -3, -4, meaning give -3, -4 to 0, comma 0. Let's say if there's a point 5, comma 6, iska bhi -3, -4. So add -3 and -4 to everyone. When you do this, 3, comma 4 becomes the new origin. The origin becomes -3, -4. 5, comma 6 becomes 5, -3, 2, and 6, -4, 2. Are you clear with this? This is how you shift an origin. So if you want to shift 3, comma 4 to origin, just give -3 and -4 to everyone, including yourself. When you do that, you become a new origin and everyone else will change. This is a simple mathematical concept of shifting origin. Is this idea clear? It's like, let's say your friend has 1 crore. How to make them poor? If your friend has 1 crore rupees, how to make them a poor person? Try to think in a positive way. How to make them poor in a positive way? Give all your friends 10 crores and then your friend is poor, isn't it? One thing, you can take away the money from your friend. The better way, make all the people surrounding her, give her 10 crores and now that she's poor. It is all relative, isn't it? Think of like that. So, the best way to destroy a country, right, is give everyone enough money. It's called inflation. During World War II, Germans tried to do that. They used to print pounds and francs and everything, and they used to dump the money in London. Take notes. So what happens interestingly? Just imagine tomorrow everyone gets 10 crores in Mumbai. Everyone gets 10 crores money in their bank account. Tomorrow you'll go to class, you'll catch an auto. The auto guy will say, I have 10 crores. Why will I drive an auto? You take the auto. Isn't it? You'll go to the vegetable market. The vegetable guy will say, what? Oh, I have 10 crores. Why will I sell vegetables? I'll go home. You take whatever is there on the road. Within 1 week, the city will be empty. DMart will be closed. Autos will stop running. City will fall into chaos. It'll be an interesting thought experiment. Anyways, so we study when we're in IIT, na? And when there is an exam tomorrow and you don't want to study, we used to sit and talk all this kind of nonsense stuff. Isn't it? This is the kind of things we do, right? When you don't want to study, you think about life. What is this? Why do we write this exam? All this nonsense stuff. So we used to have these kind of nonsense discussions at 3 o'clock in the night. It's a good place. You'll find a lot of weird people to meet. Someone asks you, right, why we need to go to IIT? It is to make good friends. Studying is secondary, frankly speaking. The kind of people you meet are so weird, you'll not get them anywhere else. You need to have such kind of idiots. Anyway, so we study relative motion by subtracting. So we are using the simple concept of shifting of origin. Subtracting velocity and acceleration of observer from everyone. Let me give an example. Let's say we have 3 people. Let's say this guy is A, who is at rest. We have B here, who is going with the speed UB, acceleration AB. We also have C here, who is going with the UC and acceleration AC. And now we will say we want to study with respect to B. Now, this is your choice. You can study with respect to anyone. So if you want to study with respect to B, what should I do? Take B ka velocity and B ka acceleration and subtract it to every one. Meaning I will take UB backward. I will take AB backward. I should do this for everyone. So I'll subtract UB backward. I'll subtract AB backward. Same thing, vector really, right? We're at I cap, J cap, you're subtracting it. So I'm just showing you the pictures. So you have to put UB backward and AB backward. Perfect. Now when you do this, what will happen? B ka velocities and accelerations will cancel. So B will come to rest. B will say, okay, I came to rest. And B will say, oh, this person A is going back with speed UB and acceleration AB. This is what B will start thinking about everyone. And he will think this guy C is actually going with UB minus UC, UC minus UB. I'm assuming C is greater. And AC minus AB. Is the logic simple? So these are velocities and accelerations as seen by B. B will think C is going like this. That's it. This is the simple idea. Once you do this, and after that, you use your regular kinematics. Everything I taught you so far is valid. Got an idea there? Let me give you one more example. What if projectile motion, we do have it in two-dimensional. Let's say u1, theta 1. We have another particle here, u2 and theta 2. Let's say this is A and this is B. And you want to study with respect to B. Step 1, resolve the velocities into components. So let's do that. So this is u1 sine theta 1, and u1 cos theta 1, u2 sine theta 2, u2 cos theta 2. Gravity, g downward, gravity, g downward. You want to study with respect to B, so reverse the B ka velocity and acceleration. So reverse will be u2 sine theta 2. Remember, you have to do the same thing for this guy also, u2 sine theta 2. So whatever you subtract from B, you have to subtract the same thing from everyone. u2 cos theta 2, u2 cos theta 2. So if you keep it right here. Gravity g upward, gravity g upward. You just put everything in reverse. And now if you ask B, B will say, okay, I came to rest. All got cancelled. That's what we wanted. And if you ask him, boss, what do you think about A? B will say A is going horizontally. Now look at this. These two are adding up. Same direction. u1 cos theta 1 plus u2 cos theta 2. And in the vertical direction, it is going with u1 sine theta 1 minus u2 sine theta 2. And interestingly, look at this. Gravity got cancelled. Gravity also got cancelled. And it will say the relative acceleration is 0. So B will think A is going with a constant velocity. This is the acceleration with respect to B. You're getting, I'm showing you all with pictures. We can write this mathematically also. I'll do that also. But yeah, pictures will give you more sense. So you know what B will think? B will think A is going with a constant velocity in a straight line. So this is what, technically speaking, A is going in a curve, B is going in a curve. They're going in parabolas. But B will think A is going in a straight line. This is the path of A as seen by B. Means if you and your friend jump from two different buildings from different heights, you will still think that guy is going in a straight line, even though in reality both are going curves. So these are the few things A, B will think. So B thinks A goes in a straight line because there's no acceleration. B thinks A is moving with constant velocity. So this gives to a theoretical statement. Motion of one projectile with respect to another projectile is always straight line. So it doesn't matter. You take two particles and you throw them. Yeah. Motion of one projectile. So yeah, the skydivers ka thing. Motion of one projectile with respect to another projectile. So technically in the ground, both are going in parabolas, but they will think the other guy is going in a line. All clear with this logic there? So resolve the velocities, get the components, subtract them from everyone, and then you'll get a new velocities. So you'll get new velocities and new accelerations, and then use your regular kinematics. This is how we will do most of the problems. I don't like to put that mathematical things, but if you like, it is great. I'll show you that also. So it's just a matter of convenience. I like to draw pictures, so it looks more easy for me to understand. So, but if you're convenient with vectors and stuff, great. So this is the representation. When we write V A comma B, the meaning of this is velocity of A with respect to V. That is how we read this. V A comma B. Velocity of A with respect to B. So this is written by velocity of A with respect to ground frame, velocity of B with respect to ground frame. This is what I was saying. Subtract B ka velocity from A, you'll get relative velocity. So from here, we can write velocity of A with respect to ground. If you just shifted that side, velocity of A with respect to B plus velocity of B with respect to ground. Think of that moon ka example. So velocity of moon with respect to the sun This will be velocity of moon. This is also important. Like, later on when things become more mathematical, pictures won't make sense. It becomes difficult to see in pictures. So moon with respect to earth and earth with respect to sun. So you can actually combine like this. Similarly, if you write acceleration a comma b, this is the acceleration of a with respect to b. This is the notation. Same story, acceleration of a with respect to ground minus acceleration of b with respect to ground. Once you got this v relative and everything, so v relative will be d r bar relative. So just add everywhere relative, relative, and you're done. Everything will be valid. dt. So if you take relative velocity and differentiate, you get relative acceleration. If you take relative position and differentiate, you get relative velocity. So a relative will be dv relative. I'll just put r dt. This can be also written as v relative, dv relative, dr relative. So just keep adding the words. If a relative is constant, like I said, once you subtract the velocity, it is just your regular. Then we can use the equation v final relative is equal to u relative plus a relative t. The three equations are valid. S relative is u relative into time plus half a relative time square. I am putting in vector form. V relative square minus u relative square is 2a relative s relative. All clear with this? Any doubts on this? So once you subtract that velocity, then it's regular kinematics only. Any doubt so far? Idea is clear. Great. So steps to solve a problem. So when you see a relative velocity ka thing, how do we do this? First thing, when you see a problem, how do you know you have to use relative velocity? I'll show you one or two questions, then we will see what makes you think you have to use relative velocity. But how to solve? Step one, choose your reference frame. So let's say 3, 4 bodies are moving. First, you decide whom you want to stop. And it is your choice. It doesn't matter which one you take. But by taking a certain frame, sometimes your life becomes easy. So yeah, that we have to figure out. So choose your reference frame. Will you stop A or will you stop B or will you stop C? Doesn't matter. You can decide anyone. Step two, subtract velocity and acceleration of the observer from every one. Same thing, whatever I told you, I'm putting it in detailed steps. And this is what I keep telling you. Don't buy hard the problems, buy hard the process. When you know the process, you will be able to understand when to adjust. Subtract the velocity and the acceleration vector of the observer from every one. From every system. Now, observer behaves like a fixed point. Because you subtracted his own velocity, he will come to rest. So this guy will see new velocities and new accelerations. Step 3, use kinematics to solve. If a relative is constant, use the three equations. If it is not constant, then use integration and differentiation. So when do you know you have to use relative motion? Now again, this is not a concept, but when you solve a lot of problems, you'll get an insight. Okay, maybe yahan pe aisa hoga. Generally, this is the idea. If multiple bodies are involved, like 2 to 3 things are moving at the same time, it becomes really difficult to see all of them at the same time. So, and we are interested in motion between them. We want to see what happens of A with respect to B and all that stuff. Generally, relative motion is preferable. Not compulsory, but this is just an insight. This is what I realized over the time. If there's only one particle moving, there's no meaning of relative velocity. If there are 2, 3 particles moving and you're asking how does that guy look with respect to this guy, most of the time it is a relative velocity. This is what I keep saying. So when you solve questions, right, just don't get the answer and go forward. Ask yourself, what else could I have done? What made me think this way? Why did I think this way? Once you ask those questions, right, you will get your own insights. Just to give an idea, abhi tak dekho, we did almost 56 questions. How many particles are there? One particle, isn't? One particle is bouncing between the walls. How many are there? One particle. How many are there? One particle. How many particles? One particle. One particle. One particle. All these are only one particles. Observe karo. Yeah, first time you got two particles, but that also was we were able to manage. We never dealt with two particles at the same time in most of the cases. So that's the idea there. All clear with the steps? Let's see a simple question and then we'll go ahead. Let's say we have two trains on the same track, A and B. Pretty common thing. Mumbai ka locals, right? They go on the same track. Let the distance between the trains is 1,000 meters or 1 kilometer. So the train B is going with a speed of 36 kilometers per hour. The train A is coming from the back with a speed of 72 kilometers per hour. Then train A saw the train B and said, "Oh shit, I'm going too fast," and he started applying brakes. I'll write all the story though. At the same time, B also realized A is coming and he started accelerating with A by 2. Generally, this is what happens. If your train is at Thane and there is one more train at Mulund and that is coming from the back, so Thane ka train will accelerate and Mulund ka train will start decelerating because it has to stop, right? And we don't want the trains to collide. So two trains, A and B on the same track, move with 72 kilometers per hour. Remember, you have to convert them into meters per second and 36 kilometers per hour. So A is going faster than B. If you don't apply brakes, you're going to hit B. When distance between them is 1 kilometer, A decelerates with A. So A started applying brakes. And B accelerates with A by 2. Now just imagine if A ka value is very, very small, then what will happen? The trains, right, will not be able to stop in time. They will hit each other. So find the minimum value of A so that there is no collision between them. If you apply brakes really hard, this will stop. So you're safe. But what is the minimum value? You just avoided the collision. Find the minimum value of A to avoid collision. We don't want A to go and hit the train B from back. I hope the story was clear. Get the value of A. Now see, it is clearly being, now look, notice that two things are moving and you don't want to collide with them. So it is something related to both the motions. That is the idea there. Oh, this is looking like relative motion. You can do this normally also, but it becomes lengthy. Take a minute, think, then I'll show you this. Remember the steps. Choose your reference frame, subtract the velocity, use kinematics, but plus that is the steps. So A and B both are moving, you can stop anyone. Try, take 2-3 minutes, and I'll show you. That's it. If you got this idea, you're done with relative motion. Concept wise, we will see problems though. And this is what I keep saying. Physics may you really don't have big, big concepts. What are the concepts you learn? Like simple concepts, right? Three equations. A is equal to dv by dt. V is equal to dr by dt. The same things I'm repeating every time. But we did 57 problems so far. And how many of them repeated? Okay, Anish got something. Karthik got something. Yeah, we have two people. Others try. नहीं युक्ति check करो एक बार calculations. I know some of you are already done in your classes, so but still give it a try. Right, Prisha. So step one, stop any one. Whom will you stop? I'll stop B. You can stop A also. Nothing wrong. So first convert them into meters per second. How do you convert into meters per second? 5 by 18. So I hope you know that. So if you do this is 5 by 18, this will be 10 meter per second. This will be 20 meter per second. Perfect. So let's do with respect to B. I'll write the whole thing once, okay? So, but later on I'll start skipping steps. So this guy is going with a speed of 10 meter per second and going with an acceleration a by 2. A is going with 20 meter per second and going backward with acceleration a. You want to stop B. So what should I do? Subtract 10 backward, subtract 10 backward, subtract a by 2 backward, subtract a by 2 backward. So even though I subtract for that, it'll add up. So now because of this, B will come to rest. B will think, oh, I am fixed. Suppose if you're sitting in B in the last compartment and if you're looking at train A, this is how it looks. So this person in train B will think, now they A ka speed becomes U, 10 meter per second, 20 minus 10. And the acceleration has become 3A by 2. Isn't this how it looks for B? Now the question has simply become one particle problem, isn't it? Instead of two people moving, now there's only one person moving. It becomes so easy to see. Hope that thing was clear. So once you got this, then what would happen? Because you're decelerating, you will come closer. And just before hitting B, you want to stop. So at this point, V will become 0. Now be careful. This is not the velocity. This is V relative. So B will think A came to rest just before collision. So to avoid collision, B sees A coming to rest just before collision. Then you're done. So we know all the data. V relative square minus U relative square is equal to 2A relative S relative. V relative is 0, U relative is 10 square. A relative is minus 3A by 2. Be careful, right positive, left negative. S relative is 1000. We get A is equal to 1 by 30 meter per second square. So easy. Now, just to be a little more cautious here, when you say V relative is 0, this implies velocity of A and B has become equal. A didn't stop. In order to avoid collision, you need not stop. Think about this. Let's say you're running in front of me. Okay. You're running with 10 meter per second. I am running with 10 meter per second. Can I ever catch you? So in order to avoid collision, I need not stop. If the speed of train B becomes greater than or equal to speed of train A, then A cannot hit B, isn't it? So train A is actually not stopping. So it doesn't mean A stopped. A is still moving. So be careful with that. B thinks A came to rest. In real life, from the ground frame, A is still moving. It doesn't mean A is at rest. Suppose if you want to do this problem in the ground frame, you know how to do? I'll just give you an idea and you'll see how lengthy it is. Initially A is here, B is somewhere here. So we have to start like this. Let's say the train B has reached here, the train A has reached here, meaning A has traveled this much distance, B has traveled this much distance. Let this distance be x. A traveled 1000 plus x. Just to avoid the collision, at the point when they're about to collide, velocity of B and velocity of A has become equal. So velocity of B and velocity of A, these two are equal. And let the time be t. Then we'll write 100 plus x is equal to 20t minus half at square. Then we let x is equal to 10t plus half a by 2t square. Then we'll write VA is equal to 20 plus acceleration minus 80. VB is equal to 10 plus a by 2t. And then we'll say these two are equal. We'll get the time from here. Then we'll put it here. That's a lot of work. You will get it. You can do it in the ground frame. But with relative velocity, you can see you just get it with one equation, isn't it? Instead of seeing two guys moving and doing all nonsense, you stop one person, your life suddenly becomes easy. Any doubts on this? That's what I mean by when you do in a relative frame, sometimes problems become really easy. Sometimes it can get more messed up. So you have to use your judgment. Clear with this? Take a break. Come back by 9:45. We'll continue from here. We'll see more problems on this. Any doubts so far? That's the theme of relative. Come back by 9:45. Take a break. Let's see the next one. Chalo, cams on everyone. Let's say we got a building here. Height of the building is 50 meters. We have two particles. A is projected down with 20 meters per second. There's another particle B is projected up with 30 meters per second along the same line. Gravity is G. A and B are projected towards each other along the same line from a building as shown. So they are going to collide. Find the time and the position where they collide. See, if you see the whole language of the question, right, it is always about two particles, something is happening between them. It's always like that. Try. Get this, everyone. Again, remember the steps. Step one, choose an observer. नहीं आना. Anish got it. Prisha, एक बार check करो. The distance part I think is wrong. Anish got it. So the time is fine. Get me the second part also. नहीं Karthik. Time wrong. You did something. Get the distance. Get me both the answers. You have to tell me both. Time, most of you are getting it. Right, Yupti? So listen to this thing. Step one, choose any observer. So I will take B or I can take A. It doesn't matter. You can stop any one. So let's stop A with respect to A. Remember, gravity is also there. So what we do, we have to put 20 upward, 20 upward. Gravity G and gravity G. Now, if you ask A what is happening, A will say, okay, I came to rest. I'm not moving anymore. But this person B is coming towards me with a speed of 20 plus 30, 50 meters per second. And what about the acceleration? G and G also got cancelled. A relative is 0. So A will think B is coming towards me with a constant speed of 50 meters per second. And what is the distance? 50 meters. See, that is what A thinks. So S is equal to ut plus half at square. S is 50. U is 50. Time is t. Acceleration is 0. Time is 1 second. means they are going to collide with each other in 1 second. So be careful how you're subtracting it. Now here, one important thing you need to understand, time in all frames is same. Means whether you stand on the ground, you stand on B or you stand on A, they are going to collide in 1 second only. So whatever time you got with respect to A, you can use the time in any frame. Time in all frames is same. Is that making sense why time is same in all frames? Time is same in all frames. Because think about this way. Let's say you and your friend are meeting in a railway station, right? And you both are walking towards each other and you meet in 5 seconds. Okay. Now, if some person who is going in a train sees you both, what time he will see? 5 seconds only, right? Why will the time change? Because some guy is running on the road. You both will always meet at 5 seconds only. So same way, A and B will always meet in 1 second, no matter who looks at it. Now come back to the ground frame. Because you're asking where they will collide, we need to see in the ground frame. Now let the observer be on the ground frame. So even this person will see they will collide in 1 second. So this is person A going down at 20 meter per second. This is B going with 30 meter per second. Now be careful, you're doing in the ground frame. The acceleration here, we can write SB is equal to UBT plus half ABT square. U is 30, time is 1 second, acceleration is negative minus 10, 1 square. 25 meters. That means B will travel 25 meters in 1 second. Similarly, A also will travel 25 meters from 1 second because total is this. So that is where they'll collide. Middle of the building. They both will collide at the middle of the building. Is that clear, everyone? Are you clear? So A is falling down, B is going up. So this is how it will actually look in the ground frame. If you're standing on the ground, this is what you will see. A is coming down, B is going up, and they'll hit in the middle of the building. This is what A will think. Are you clear with this? So you can use relative velocity, get the time, then go back to the ground frame and do the problem normally again. Is everyone clear with the approach? That is how you can handle things. So you can keep switching between two frames. You can do it in the ground. You can go back to A. You can go back to B. You can keep doing this. So you can get time from one relative and you can do it in the ground again. Let's see one more. So we have two vehicles here. Let's say B is going with speed U. This is 0 comma t. This is A, which is also going with speed U. This is 2d comma 0. So we have two vehicles going with the same speed along x and y axis. Find the minimum distance between A and B. So A and B move with speed u along x and y axis as shown. One thing is clear, right? They both won't meet because by the time this guy comes to origin, this guy is still here only. And by the time this guy comes to the origin, B has already gone ahead. So they're not going to meet, but they will be at a minimum distance. So this is another variety of questions. These are called distance of least approach. What is the minimum distance between them? नहीं रे अनिश. How did you get what is A actually? आंसर में सब D and U तो है. नहीं, no, that's not the answer. One thing we can do with maximum minima. After time t, this will travel distance d. इसका coordinate होगा 0, d minus ut. After time t, this का coordinate will be 2d minus ut, 0. Then get that distance. Then do maximum minima. Differentiate and equate to 0. Quite lengthy, but there is a way to do that. Again, the problem is what? Because both are moving, it is difficult to see. Stop one of them. Whom you want to stop? Let's stop A or B. Anyone? I'll stop A. Or I can stop B. Doesn't matter. So this is B going with U. This is A also going with U. Let's stop A. So with respect to A. So to stop A, what should I do? I should add a vector U backward. I have to add a U backward like this. You have to add it to the right side. Now see how it looks. A will think, okay, I came to rest. I'm not moving anymore. And my distance is 2d, 0. But it will think this B is traveling. Now B is going this way. B is going with U to the right side and B is also going downward. Isn't this what A will think about B? Because you have two velocities now. So B will think A is going in a straight line like this. This is the path of B as seen by A. And this angle is 45 degrees because both are U and U. Now you tell me, what is the shortest distance between a straight line and a point? If you have a point and a straight line, what is the shortest distance between them? The perpendicular distance, isn't it? The shortest distance between a line and a point is a perpendicular distance. So from here, if you drop a perpendicular, this is your D minimum, the minimum distance. I'll just call it D min. Then you're done. So this angle is 45. So this angle is also 45. This angle is also 45. And we know this distance is D. Why? Because this distance is D initially. Tan 45, so that is D and D. This distance is also D. Why? Because this is 2D, 0. So in this triangle, so we get D minimum will be simply D sine 45, the opposite side. This will be D by root 2. This is your minimum distance. All clear the steps? See, once you stop A, suddenly the whole problem became a single straight line, isn't it? That's it. That is the whole thing about relative. When two people are going, it looks confusing. If you stop one guy, suddenly the problem becomes about one person moving. And you guys are, we have already done enough problems, when one person is moving, you can handle that. हाँ ना, we can do that. We take that function. But उसमें what you can do ना, you got s is equal to root, right? You can actually do s square. And you can say if s is minimum, s square is also minimum, right? That way it will save you little time. So you can do with maximum minimum, it works. Any doubts on this? D by root 2, all clear with the process? Let's bump up the level. Idea is this. So if two things are moving, stop one guy, the other guy will come to rest, the other guy will go in a line, drop a perpendicular. So let's say we have two buildings. This is H1. This is H2. Distance between the buildings is D. We have a particle A here projected with speed U1, theta 1. We have a particle here projected with U2, theta 2. So technically, this guy is flying like this guy is flying like this. Both are going in two parabolas. Find the minimum distance between them. That would be little lengthy. And find the condition for collision. That's a standard model. If A and B are going to collide, what is the relation between all these variables? How many variables are there? U1, U2, theta1, theta2, H1, H2, D. 7 variables. Exam they can give you 6 and ask the seventh one. So find the minimum distance between A and B. Again, we are assuming no one falls on the ground before. Find the condition for them to collide. Let's get the first part. But I'll tell you one thing. If I got the first part, if two particles collide, what is the minimum distance between them? 0, right? If D minimum is 0, that will come, the B part will come. So get the first part. Find the condition, find the minimum distance between them. If the second part में अगर angle और कुछ है, तो let's say this is V and this is U, and this angle will be tan alpha. Tan alpha will be how much? Opposite side V by U, na? You can find alpha from there. So if that is alpha, this is 90 minus alpha. So this is 90 minus alpha. From there you will get it, isn't it? You can get the angles. I just gave U and U because it looks nice or nothing else. You can change the numbers. Let's give it a try. All variables, but that's what makes the problem really good. Yeah, answer you won't be able to type. It's pretty big, but give it a try for 2 minutes and I'll show you. Then you can see whether you got the same thing. Okay, the story is the same. You have to stop someone. First, let's resolve the velocities into components. Keep doing. By the time I start, it'll take another minute. So step one, get the ingredients ready. So resolve the components. U1 cos theta 1, U1 sin theta 1, U2 cos theta 2, U2 sin theta 2. This guy has a gravity G, and this guy also has a gravity G. Great. This was A and this was B. Let's stop someone. I'll stop A. With respect to A. So what should I do? Subtract U1 sin theta 1 downward. I have to do the same thing even for this guy, U1 sin theta 1. u1 cos theta 1 to the left, gravity up, u1 cos theta 1 to the left, gravity up. Now when you do this, A will think, okay, I came to rest. And B will think, now I'm going up with u2 sine theta 2 minus u1 sine theta 1 and horizontally with u1 cos theta 1 plus u2 cos theta 2. And what is the relation? Acceleration A relative is 0. Is this clear so far? This is the velocities. That means A will think this guy B is actually going with a constant velocity in a line, something like this. This is the path of B as seen by A. Now you can ask me, sir, how do you know it is going like this? It can be like this, can be like this. I know. I'm just taking it. The angles will take care of themselves. So don't worry about that. Path of B as seen by A. Let this angle be alpha. How to get alpha? Tan alpha is Vy by Vx. So what is the vertical velocity? u2 sine theta 2 minus u1 sine theta 1. So by u2 cos theta 2. Because I gave all variables, it looks big, but numbers are given, that alpha would have been some angle. So this particle is going with an angle alpha in a straight line as seen by A. What is the minimum distance? A perpendicular line from A to B. This is your D minimum. Now we got a triangle here from A to B. Join this line. So far, this is clear. So let me show you in the next page. So it's all geometry at this point of time. So I know alpha ka value. So these are the angles. So that angle is alpha. And this, what is this angle? Let this angle be theta. Look at this angle here. This height will be, for this triangle, this will be h1 minus h2. And this distance is d. So we get tan theta is equal to h1 minus h2 by d. That means this angle in the middle is given by alpha minus theta, because this full angle was alpha. This full angle was alpha. So this angle would be alpha minus theta. So now we got a triangle which looks like this. 90 degrees. This is A. This was B. This angle was theta, alpha minus theta. This was your D minimum. We get D minimum is equal to AB. AB is your hypotenuse, sine alpha minus theta. And what is AB? AB is again root over h1 minus h2 whole square, Pythagoras theorem plus d square. The total three variables. AB is this, theta is this, and alpha is this. That's what I said. This is a little complex. If numbers are given, you would have got something, but this is how we do with variables. But is the whole process clear, everyone? Got this? And then what is the condition for collision? Now, if they're going to collide, then alpha must be equal to beta. Meaning you can look at this picture only and do it. See, if they ask you find the condition for collide, that is actually the easiest question. They can actually ask that. This will still be lengthy. But any doubts on this part before going to the second part? Now, for the second part, look at the story here. The same picture, I'll just draw a little differently. You want the condition to collide. Now you tell me, we know A thinks B is coming in a straight line. So if B wants to go and collide with A, how should you travel? If B goes this way, will it collide? If B goes this way, will it collide? That means if B wants to collide with A, the B should go in such a way, it should pass through A, isn't it? So for B to collide, the velocity vector must be along AB bar. For collision, the path of B as seen by A must pass through A. Basically, the velocity must be pointing towards A. That means this angle, whatever you get, this angle alpha. So tan alpha will be ut sine theta 2. So basically, theta becomes equal to alpha u1 sine theta 1 by u2 cos theta 2 plus u1 cos theta 1. But this is also equal to the height of the building, h1 minus h2 cut difference nd. This is also equal to h1 minus h2 by d. There, that is the condition, everyone. If you satisfy this condition, they will collide. This is the condition for collision. So indirectly, I'm saying for them to collide, alpha should be equal to theta. For collision, d minimum is 0. That is, alpha must be equal to theta. But if they just want you for the condition for collision, this is a much better way to do instead of doing all that stuff. Is this clear, everyone? So after stopping A, whatever velocity you get, that should pass through the other guy, and that means you're going to collide. Now, if you try to do this normally, it's very difficult. Like, think about it. A is going in a parabola, B is going in another parabola, and they're colliding somewhere here. It's a mess. Now, you can write this in a vector form. This will be another good question if they ask you mathematically. What is the vector condition for collision? So if you have two particles going in three-dimensional, so this is the main idea there. Think about this. If two particles are going in some random direction, y component will be equal. Not necessary, na? If both are on the ground level, then you would have said that h1 minus h2 bhi hai. You're getting it, Yukti? If both the particles are projected from the ground level, then the vertical components must be same. Look at this statement here. Let's say you're running somewhere. Okay, I am also running in some direction. So if I stop myself, I'll get a relative velocity. Now you tell me, if you have to come and meet me, your velocity should be in which direction? Towards me, right? That means the relative velocity vector and the relative position vector must be anti-parallel. So if you take 2 points and join them, that vector and the velocity vector must be opposite. That is when they will meet. Must be anti-parallel. This is under the assumption A relative is 0. If A relative is there, then it becomes more messed up. We will not get into it. So this is how it will look, everyone. So this is A and this is B. So this vector will be AB bar. So if B and A wants to meet, the velocity vector must be in this direction. This must be VAB bar. Both should be opposite to each other. So if two vectors are anti-parallel, that means VAB cap must be equal to minus RAB cap. The directions are opposite. What is VAB cap? VA bar minus VB bar. by divided by its own magnitude, VA minus VB bar, minus RA bar minus RB bar by divided by its own magnitude. This is the vector form everyone. This is the direction of relative velocity in unit vector, and that is unit vector along this. So the negative sign indicates if both are in the same direction, the distance will keep increasing. This is the vector form for two particles to collide in 3D. Negative sign indicates AB is decreasing. Is the logic making sense, everyone? All clear with this? It's a good one. Little lengthy, but do check it out. Next one. Let's see one more, last one for the day. This was also a PYQ. Top view. We got a road here. The width of the road is 4 meters. So in this road, there is a bus which exactly fits the road. There is no gap only. The bus is also moving with a speed of 4 meters per second. So you're standing somewhere here and you want to cross the road. You're also standing at a distance of 4 meters. I'm keeping everything 4. And you decided I want to cross the road. You're looking this from a top, okay? It's a drone ka view. So the bus fits exactly on the road and moves with 4 meters per second. At a distance of 4 meters, a boy walks with speed u and crosses the road, speed u, and crosses the road safely. We don't want to kill anyone. No, you can run really fast. He can just shoot off with full speed and cross the road. But what is the minimum speed? What is the minimum speed you can walk and still be safe? He can run with 200 meters per second and cross the road. Right? He can do anything. But there is a minimum speed. Maximum could be anything. If you go anything less than that, there is no way you will cross safely. So let's see how to do this. Nere yukti. How did you even get one? Nere Anish. What should be the minimum speed so that he crosses the road safely? I'll tell you one small thing. Did I say he's going in a straight line? Bus, now think. तो logically सोचो ना अगर बस ऐसा आ रहा है you'll walk like this or you'll run away from the bus or will you just walk straight and keep looking at the bus like this? You don't cross the road like that, right? You actually try to drift away from the bus. So now try. In case you're still wondering, this is how you start. Let the boy walk with speed u at an angle theta. Is a start karo. So theta is a variable. For different thetas, he'll go with different speeds. In that, there is a particular theta for which you get a minimum speed. So that's how you start. If you say, no, sir, how do you know he's going at an angle? ठीक है ना? Let him go in a straight line. Then theta, prove theta is 0. Getting it? So if he is actually going in a straight line, theta will turn out to be 0. Max will take care of it. We should not assume anything. Try. It's okay to get a wrong answer. It's okay if you don't get it, but put a fight. No, he's walking in a line. Abhi. Let's not put a curve and he's dancing and doing all that stuff. No. Let him just go in a straight line. Already this itself is a mess. Curve and all he can go and there'll be infinite possibilities then. Someone will say he will just wait there, wait till the bus goes off. And then he'll crawl on the floor. Then he is just walking in a straight line. Yeah. Again, you can clearly see, right? Two people are moving. What are the two? The bus and the man. You have to stop someone. Start from there. Always start from the process. That's what I said. You see two things moving and you're asking something related to them. When will they collide? When will they meet and all that stuff? So stop one of them. Stop the bus. Stopping the bus is the most decent thing. Stopping the man, right, Ahana? Yeah, one answer. Right, Prashant. You have two answers. So let's stop the bus and let's see what the driver will say. Now we don't know. Let the boy go with speed v at an angle theta. So if you look at the components, we have v cos theta going forward and v sin theta going this way. So you might think like, sir, why should we go like this? So the reason is this. When you go like this, the v sin theta, right, is making you go away from the bus. So it is actually giving you a little more time to cross the road, isn't it? You are using your velocity to do two things. One, to cross the road. One, to give you more time. See, this is how you fight with an enemy. When you're fighting a war with an enemy, right? There are two ways you can defeat them. One, you can overpower them and kill all of them, or you can destroy their supplies. You can send a small troops into their camp and destroy their food supplies or poison their water and everything. So there are two ways to fight a war: make them weak, or you become more stronger than them, or you can do both. So here we are doing both. One velocity is trying to increase the time because you're going away from the bus. One velocity is trying to cross the road. So there is a fine, balance somewhere. Both will be an optimal solution. So let's stop the bus. So if you stop the bus, we can write like this. Let the boy go at an angle theta. So this theta is variable. So what should I do? Put 4 backward. Put 4 backward. Now the bus will think I came to rest. Now, if you look at the boy velocity here, you will see vertically you're going with v cos theta. Horizontally, you're going with 4 minus v sin theta. Now look at this. Suppose if the boy goes very slowly, speed is very less, what do you think will happen? Then his velocity will be like this, isn't it? He'll go and hit the bus. This is what the driver thinks. The driver looks like this. Driver ko lagega the boy is coming and falling on the bus. If you go little faster, then the boy will go and hit here. If you go little faster, the boy will hit here. If you go little faster, the boy will just miss the bus, isn't it? If you go even faster, the boy will go like this. You're getting all these lines are different paths as seen by the driver in the bus. It all depends on how fast is the boy walking. So if the boy just wants to miss the collision, what should happen? This is the path where he will just miss the bus, isn't it? So this is the path where the boy just misses the bus. This is a minimum condition. So this red line is the path as seen by the path of the boy as seen by the bus. This is what the driver will think. and this path should just miss the bus. You're done. So then what is this height? 4 meter. What is this height? 4 meter. Then what is this angle? 45 degrees. Because it is 45, 4 and 4. So tan 45 is the vertical velocity, v cos theta, vy by vx, by 4 minus v sin theta. This becomes 1. So indirectly, we got v cos theta is equal to 4 minus v sin theta. At this point, this becomes a max question. You can do maxima minima, or if you have done your trigonometry, you will get v is equal to 4 by sin theta plus cos theta. So for v minimum, the denominator must be maximum. If this is maximum, then v will be minimum. Remember this thing, this is useful. A sin theta plus b cos theta, if you have a trigonometric function like this value is always less than or equal to a square plus b square. Did you guys study this in maths? This is a trigonometric result. A sin theta plus b cos theta is always less than or equal to root over a square plus b square. So using this logic, sin theta plus cos theta is always less than or equal to root 2. Therefore, the minimum speed will occur when the denominator is maximum. The denominator ka maximum value is root 2. This is 2 root 2. Okay with this. And this actually occurs when theta is 45. That means this boy is actually going with a speed of 2 root 2 meters per second at an angle of 45 degrees from the bus. If you go that way, you can cross the road safely with a minimum speed. This actually came in the advanced question. This was a previous year question. I think, I don't know, 7, 8, 10 years back. Long, pretty old question. Yeah, that's one standard model there. Any doubts on the structure? Yeah, you should not be scared, right? So if you got an answer, be confident about your concept. You can put it there. Clear with this. So what is this thing actually? So this is the speed for different angles, right? So when we got v is equal to 4 by sin theta plus cos theta, this quantity is the speed of the boy for different angles. If he goes with different angles, let's say he decides I want to go with 30 degrees. You should go with this speed to be safe. So among all those angles, there is one angle which will give a minimum speed. Speed of the boy for different speed of the boy for different angles. Yeah, like you said, if he decides to go straight, then theta is 0, you'll get v is 4. So different angles will give you different answers. All clear with this? There, that is one. So if you see there, we did all some good problems, like these are all based on relative motion. Next class, when we catch up, we are going to do some more higher level problems. We have, particles chasing each other. That is the most important one. That things will come really good ones. We have something like that. And then we will do the standard problems, Rain Man, Riverboat, Umbrella problems and all that stuff. Those are the standard models. We will still do some different ones in the next class. Mostly next class, we should be able to finish off most of relative motion. I think by next week, we should be able to wrap up the chapter by finishing off graphs. No, I think it'll take another 3 more classes. So, okay. But we have almost done. We did almost 61 questions, everyone. So I think by the time we wrap up the chapter, we'll hit around 75 questions. So it's a big chapter. Among all the things we have, this is one of the big one. The next biggest chapter is rotational mechanics. That will cross 300 pages. So yeah. Anyway, that will come somewhere in December. Okay, I think with that, we'll wrap up for the day. So please make sure to go through the notes, right? And start solving if you have not started. So and then there is an exam on Friday. Please, everyone, make sure to give. Don't miss the exam. So any doubts, anything else, you can stay back and ask, or also free to leave. I'll see you guys again next Monday, same time. So take care, stay safe.